Welcome back for another peptide tutorial, peptide enthusiasts. So today I'm going to do some additional design that I didn't share last time. And so this time I'd like to make a peptide even faster than I did last time. And this is going to involve building a biopolymer from a sequence. And this happens to be one of my peptides. It's a pre-pro peptide sequence. I can just control V it in. I'm just going to make it a random coil for illustrative purposes. And what I would like to do is I would like to color code this peptide, because there's a number of architectural features that it has, and instead of just pasting a boring multicolored solid line into a figure for my dissertation, I thought this would look a little better. So here's what I'm going to do. The first 19 amino acids are a signal peptide sequence. And so I'm going to go down here and highlight the first 19 amino acids. I'm then just going to color it. I think this will work. Now, my advisor is much more aesthetically competent than I am. And so he shared a color palette with me recently. So I'm going to take advantage of his much better aesthetic sense. Yep, okay, that does work. Okay. So I'm going off of something he shared about a 6-color palette. So if you Google that and these HTML codes, maybe you can find the same thing I'm looking for. So you can use these HTML codes to actually specifically pick something on this color grid. And you can see that that worked like a charm. And so hopefully I'll be able to do the next one a little faster. The next 10 amino acids are just an anionic sequence that helps bind and neutralize my antimicrobial peptide of interest while it's being processed and trafficked. That looks good. The next 23 amino acids are that's what becomes the antimicrobial peptide, believe it or not. And then comes a glycine residue, which for many antimicrobial peptides, there's a glycine that comes at the end that will be the site of a post-translational enzymatic reaction to actually chop off part of the amino acid and leave behind a C-terminal amidation. Just referencing colors of interest 255. P79 to get a nice blue like that. And then the remainder is just a second anionic piece to help neutralize the peptide during processing. Oops. Yeah, there we go. Then I'm just going to fit it. Maybe play with rotation. Really want to make sure that lone glycine residue can be seen. I think I will just make that a different color, but what color? Maybe a green. Let's try that again. I like it. I think I just want to try to change the final piece to something lighter. Maybe like a light brown. All right, that looks good. So now, just like last time, save an image. It's a TIFF. This is going to be my clavin A pre-pro peptide. 300 pixels, deep dots per square inch. Transparent background. There we go. And that's it. This was a quick video, but when I realized that I was going to do this task, I figured I could just make a quick video to show how to do that. Hope this is helpful to someone out there. Be well.